y equals 0. Okay, here is another example. Again, we want to find any holes first. And to find holes, we factor the numerator, which doesn't factor, and the denominator. Again, this denominator is difference of squares. One way you can think of it is, are there factors of negative 9 that would add to equal 0x in the middle? And we could factor this as x plus 3, x minus 3. Oh, this one has a hole, and the way I know that is because notice I have a factor of x minus 3 in the top and a factor of x minus 3 in the denominator, which can be canceled. That's when you have a hole, when you have a factor that can be canceled from the top and the bottom. And my hole, what I do is I take whatever I canceled and I set it equal to 0. And that tells me the x value of where my hole is. So I have a hole at x equals 3, but it is a point. A hole is always a point, so we need to go back and find the y value. To do that, look at our function that's left over. We have just 1 in the top and x plus 3 in the bottom. So we plug our new function is p of x equals 1 over x plus 3. We want to find the exact location of the hole, so we take that x value we found of 3 and we plug it into the remaining function after we've canceled those factors. And if we do that, notice we're going to get 1 over 3 plus 3, or 1 over 6. So we have a hole at the point x equals 3, y is 1, 6. Okay, so there is our hole. Now we can go find our asymptotes. And the reason we want to find holes first is because when you're finding asymptotes, you don't want those holes to be included in your function. So when we're finding asymptotes, we just use whatever is left. Okay, after we've canceled for our holes, this is what is left of our function, 1 over x plus 3. Okay, so then we go through the steps to find our asymptotes. Remember, the vertical asymptotes are wherever the denominator equals 0. So we take the denominator, x plus 3, and we set it equal to 0. We get a vertical asymptote at x equals negative 3. For horizontal, you look at the degree of the numerator and the degree of the denominator. The numerator has degree 0 because it didn't have any x's at all. And the denominator has degree 1. The degree of the numerator is less than the degree of the denominator. So that tells us that our horizontal asymptote will be at y equals 0. Anytime the degree of the numerator is less than the degree of the denominator, your asymptote's y equals 0. So my answer is, I have a hole at 3, 1, 6. I have erased the answer. I had a hole at 3, 1, 6. I have a vertical asymptote at x equals negative 3. And I have a horizontal at y equals 0. Okay, looking at this example, again, we're asked the same question. In order to find any holes first, we need to factor the numerator and denominator. So notice in the numerator I can factor out an x because they each had an x, and I'm left with x squared plus 2x minus 8. And in the bottom, we'll wait 1 second to factor that. So in the numerator, I have to factor this x squared plus 2x minus 8 if it will factor again, and it does. Factors of negative 8 that add to equal 2 are x plus 4 and x minus 2. In the denominator, I need factors of negative 12 that add to equal negative 4, and that would be a negative 6 and a positive 2. Okay? And again, for holes, what you're looking for is any factors that will cancel from the numerator and denominator. Notice I don't have any. In the top I have x plus 4 and x minus 2. In the bottom I have x minus 6 and x plus 2. None of those are the same, so I cannot cancel any of them, so there are no holes. So then we just carry on with our original function and go to find our asymptotes. For the vertical asymptotes, you set the denominator equal to 0 and you solve it. So here's our denominator. We would factor that to solve, and we already talked about factors are x minus 6 and x plus 2. And we set those equal to 0 and solve them. So I get vertical asymptotes at x equals 6 and x equals negative 2. Those will be my vertical asymptotes, are those lines. Now I find horizontal, and remember horizontal asymptotes, we have our instructions down here. We look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 3. The degree of the denominator is 2. So we look down and we have greater than, the degree of the numerator is greater than the degree of the denominator. And it says if that happens, down here on this bottom line, there are no horizontal asymptotes. So we have no horizontal either. So we have no holes. We do have a vertical asymptote at x equals 6 and one at x equals negative 2. And then there are no horizontal asymptotes. We will do one more example to give you one more example of having a hole in the graph. All right, here we go. Find the vertical asymptote, horizontal, and any hole. Again, you look for holes first, and to find holes, we factor the numerator and the denominator. So we need factors of negative 6 in the numerator that will add to be negative 1 for our middle. If we did x minus 3 and x plus 2, negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So that works perfectly. In the denominator, if we try to factor that, we need factors of negative 3 to add to equal negative 2. If we did x minus 3 and x plus 2, negative 3 times positive 2 is, I meant to say 1 here, x plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Everything is factored. We look for common factors that can be canceled. And notice both the numerator and the denominator have an x minus 3. I can cancel those, and those will be the location of my hole. Okay, so I have a hole when x minus 3 equals 0. Gives me a hole when x is 3. Now, I would find the y part of that hole, because holes are points instead of lines. We take what's left of the function, anything that didn't get canceled, and we write that down. That's what we're going to use to find the y coordinate of our hole and any other asymptotes. So x is 3, we plug that in. Our y value then would be 3 plus 2 over 3 plus 1, or 5/4. So the point where the hole is located is at the point 3, 5/4. Now we need to go and find any asymptotes that we have. Vertical asymptotes are where the denominator equals 0. And when I say that, I mean the denominator after we've canceled our holes. So we're using this function that was left over. So we set what's left of the denominator equal to 0. And we get x equals negative 1 is our vertical asymptote. Horizontal, again, you look at the degree of the numerator and degree of the denominator, and we're using, again, the function that was left over here. And so the numerator has degree 1. The denominator has degree 1. They have the same degree. So your horizontal asymptotes, it tells you in the instructions down here, you take the leading coefficient of the numerator divided by leading coefficient of the denominator whenever the numerator and denominator have the same degree. So our leading coefficient is 1 for the numerator and 1 for the denominator. So we get y equals 1 is our horizontal asymptote. So we had a hole at 3, 5/4. We had a vertical asymptote at x equals -1 and a horizontal at y equals 1.